Just realized I'm at the end of my slide deck. Right, here we go. See if there's light in this. So, a randomly titled Optimize this. Anyone actually care about optimization? Right, good. And I've just realized my clicker is dead. Right, okay. Let's move on with this. Okay, so who am I? I am Mike Elsmore. I am the internet's Muppet. I do things on the internet that usually end up being either good or hopelessly bad. So that's me usually. The wobbling is the effect that I genuinely don't know what I'm doing half the time and I look a bit confused like a dog. So this is me not at my best. I've got to be honest. We've got this woman back home who's causing some issues and I'm not there to stop her. So you're just going to have to suffer through me at the moment. So let's get on with the show. So what's this talk about? It's full stack optimization. That's good, right? However, it's not about tuning your JVM. It's not about your CD or CI pipeline. I'm sorry. Who here came here expecting something about DevOps? Oh, turns out I was just being really loud. Did people at the back still hear me otherwise? Yes, I'm loud! Nice little bit of heckling from the back there. Brilliant. Right, so this is not about tuning your JVM or any of that stuff. Who here came here thinking it was about tuning optimization of actual machine level work? Yeah, I actually don't have anything to do with DevOps, or that's what we have other people to do, not me. So this is actually about me waving my hands around a lot and explaining some optimization techniques for across your stack. So, you know, just a bunch of general techniques that most people in a complete web stack will have forgotten at some point, or just be too new to have not hit the road bumps that they usually help solve. So I'm going to treat this by following our application stacks as a cake. It's many tiers. To be precise, it's going to be a 3-tier wedding cake, even though that is not a wedding cake, but it's an entertaining gift regardless. So we've got standard 3-tier architecture. So you have your data layer, database, in-memory, file storage, etc. You then got your code layer in the middle, your actual application that's meant to do things. You hope somewhere in the world that it's doing its thing. And then you've got your client side. Yes, I've gone with Internet Explorer because, you know what? Everybody recognizes that as a browser. May not recognize it for good reasons, but they recognize it. So, and some people are going to go, OK, so you're talking about an old monolith architecture. Well, actually, services are everywhere. And they pretty much look the damn same. It's just a ton more databases and a ton more code in the middle. They're just in more places. They're just more of it. It's still roughly in a 3-tier structure. There is still data. There is still your application code. And there is still somebody consuming it somewhere in the world. So microservices, when you look at it from an optimization point of view, pretty much the same. So let us begin. So the bottom tier, databases. Who here likes, loves, or deals with databases regularly? Yay, people after my own heart because I'm a data nerd. I spent 3 years working at IBM doing data stuff, so I really like them. I'm like the only person in my entire friendship group of developers who actually appreciates databases. Everybody else just thinks they're a dirty word. So first one is picking the right tool. If you're building a large application, you want it to work performantly, pick the data storage object, storage type that works for whatever you're building. I know MongoDB can do everything, and Postgres is the universal answer to all your problems, but it's not. Seriously, it's not. The databases, it's like I even have gone on a world tour explaining that NoSQL is a lie, which is actually just me going, pick something correctly for what you're doing. So, because, you know, this happens when you pick the wrong thing. Things get on fire and explode, and yeah, that's not a great start. There's nothing good that will end of this. So, finish on the database side. The problem with not having my Right, so picking the right tool for the right job. Who here just uses the same database and the same data system over and over and over again on every application? You're bad people. Bad, bad people. I know that there's this. You always have a choice. There's always the delete key. There is try and pick the tool that does the right job. So if you're trying to do really lightweight lookup systems, look for something like Redis. If you're trying to do something really, really heavy and completely BI-based, maybe you should be looking at something like AWS's Redshift and something that's designed for munging data into weird shapes and playing with it. Pick the right tool for the job that you're doing. This works in monolith, this works in microservices. It's the same problem. It's just microservices is a really tiny version of the problem. All right, okay, next bit, reconsider your indexes. Who here just writes their indexes whilst they're developing it, going, oh, this is the primary key, here's the foreign keys, this is what I assume the data is going to end up actually doing. They run some test queries and go, this performs pretty well. Pretty much everybody in the room does that? I'm seeing enough nods that yes. These things don't actually work in production half the time. When you actually see how people are actually behaving and how they're actually messing around with your data, you kind of realize you may have built the indexes wrong. So take a look at them, revisit them, change them on how the production is, and just bring that back into dev. Just because you know how you intend the system to work doesn't mean that's how the users and the system will behave in the wild. If that doesn't work, remove the index. And no, I don't mean just delete the index from the database. I mean shove it in something that's designed to do indexing at volume. So there's Elastic, Lucene, Solar. Has anyone heard of any of these? Who here has played with these? Who here has tried scaling these beyond one machine? It really hurts, doesn't it? Yes, nodding, Solar, no, no. Yeah. These things are great at providing really quick indexing systems. And the brilliant thing is, once you take these indexes off your primary operational database, you've got this wonderful thing of, oh, I've reduced my querying a lot. It's not burning anymore. It's not burning anymore. Yes! There's also this product I discovered a little while ago called Algolia. It's like Elasticsearch on steroids. They've got all this. So when you try configuring Elasticsearch yourself, it gets quite complex when you try doing plural checks, misspellings, and different synonym connections and stuff like this. These things are really hard to manage and make it even more painful to distribute over a sharded system. So Algolia is it's got a free tier in there, which is all I ever use because I'm cheap. But it does all the really hard bits with Elastic for you. So cheeky freebie that helps. So if indexes aren't the problem, now this is one that I have come across quite a lot. Your indexes aren't the problem, and yet everything is still on fire. The database is the problem. It's the BI and the BA people. These people have decided to write a giant query that is ruining everything, and they're locking up the entire data system, and you just want them to go away and go home. However, their query has still got 10 hours to run, so you can't stop them. Awful, awful. Is there any BI and BA people in this room? I'm sorry, you're an evil person. Operational data stores do not like you at all. But there are ways around this. Data warehouses and data lakes. Who has heard of these terms? Who actually has implemented these? The BI guys. OK, the BI guy is actually sensible. Let's go with that. Right, so data houses and data lakes are just this process of abstracting the information, essentially cloning your operational store into a second place so the bad people cannot hurt you. So it's just cloning it repeatedly and just continuously chucking it into a different place so they can't hurt your application. Leave my application alone, please. So what this normally looks like in an application is code, burning database, the code still working, and then there's the evil BI guy at the end. How you'd think about it with a data warehouse or a data lake is you have your code, your database, which is talking back to your application and your users, and then you've got it in a separate database, and the evil BI guy is just on his own over there. So he's leaving the operational information alone. Optimized because you've stopped the pain. Right, next up, the middle tier, the code bit. One of these days, I'll actually find a better logo for representing applications, but surprisingly, they're really not hard to find, and I'm lazy. So, right, this is... So you wanted to know about language-specific optimization. I can't help you with that. Sorry. So let's start with something I can help you with. So you've got a large, bulky architecture. You are sending too many HTTP requests to it. Everybody felt this pain when they've put it on the cheap little server and gone, this'll do for now, and then everything's on fire because Apache and Nginx on a small machine does not last for very long at all. You go, oh nuts, I need load balancers now. Right, this actually isn't going to, this isn't, well, there is a suggestion about this. You've got that problem. Load balancers, optimization, horizontally scale your things. Who here does horizontal scaling for distributed systems? Okay. Who here hates doing it because it means you have to follow the 12-factor app? Nobody here follows the 12-factor app? Bad people. If it's horizontally scaled, it should be stateless and everything. Bad people. Right, but there is another one that I've come across recently. Well, not recently, in the last couple of years, which is you've got a guy who's looking at your app, which is then looking at a different bit of the app, which is talking to another bit of the app, which is talking to another service, and somebody's put another service underneath that, and it's just going, and nobody knows when it ends. How many people have seen this where somebody's gone, why are you sending this to 6 different services vertically so it's making 6 different HTTP requests? How many people in the room have done this themselves? Yeah, I love the honesty of this crowd. It's like, yes, I know it is bad, but it worked, so I don't mind. I'm living with this pain because it worked. So, right, the important thing here is, if you know the information you're needing to get, you should be pushing that as close to the client as possible. Try and remove as many of the steps in the middle. I know it doesn't always make sense, but occasionally, microservices aren't really good. Just make it something more optimized as a solid single service type. I know it feels quite unnatural. Why would I have this one piece of code that does one job and does it really, really well, and then stack it inside the same application? That's kind of like writing a monolith, right? Yes, but occasionally removing 6 seconds of latency from HTTP requests is a good thing. I told you, this isn't really a DevOpsy optimization talk, I'm sorry. That's a complete load of crock and you know it. Right. Unless you're Facebook, I doubt it's a problem. Just to be fair. You know, the average application doesn't have the workloads running on it that the difference between a extra HTTP request and a standalone application are negative. Oh, it's that guy who was trolling me at the front. I think they want you to repeat.
Yes, I said that if we put all our code in a single application and don't go the microservice way, we won't be able to scale it very easily as we do now, for example.
True. However, the joys of virtualized hardware, software, and disk space is the fact you don't need to care about the cost as much. So you can just put bigger units on bigger machines, and they will work slightly better. When you're after milliseconds, occasionally throwing brute force metal at it and having all the code in one place is more performant.
Well, in our case, we are not able to scale the databases.
That's because databases don't scale, and anybody who says they do is lying.
Yes, and that's why we need microservices in order to separate the queries.
Right. You've made your point. You're
Yeah,
not incorrect.
it's a very specific problem that we have, and it may not apply to everyone here.
Thanks.
Sorry for trolling you.
It's
Not
cool.
sorry.
It's cool. I can deal with the trolling. I'll admit when I'm wrong in that situation. Databases do not scale, thus they are impossible to manage the code around it. So yes, in that certain situation, it does work. However, you've just defeated the point of that entire slide. So I'm going to move on now before everything goes to hell. Right, so fire and forget. A lot of people think that this is bad practice. Sending a request and not waiting for it to complete. Everybody believes being transactional is a good thing. Hands up who believes this? Ah, people who agree with me that even in the HTTP stack and on the browser, you can do async and just not care. So fire and forget is a good thing. It's not actual performance, it's just perceived performance. You don't actually get any benefits from it. It just means you don't have to deal with it immediately. So sending a request, just getting a request header back, and then just querying for it. So you can set up things like queues and whatnot, and just have the information being fired at it, and let it do its thing. And we've got a whole bunch of technologies at which you can then return it on, because certain queues you can pub sub it into the browser. I didn't realize I could do that with Redis until recently. I have discovered I now have a love for Redis. But then there's push notifications. Who here's been rolling any push notification stuff? How much easier has it made your life just being able to go, I don't need to wait for it, I'm just going to throw it, leave it, and they can deal with it later? Yeah. It's just lovely to be able to fire and forget and leave this thing to go. And I know we've got push notifications and sockets, but long polling is still a valid way of just waiting for information, just leaving it there. It's not a bad thing. I know it's like from the 80s, and that's usually a bad idea. It's like the haircuts weren't designed to survive. But long polling is a valid way of preserving information. Right, keep it close. Who here runs in multiple data centers? Right, do you at least make sure that the application being viewed at that time, the database, the code, and all the client's assets are all in the same place? They're in the same data center. There we go. I met a guy before when I was thinking up this talk. He kept his database in West Virginia and all his assets in New York. I know it's still Amazon, but that's still latency trying to talk between data centers. Seriously, there is options in the AWS console to change the region, and you can clone it later. So yeah, keep everything close together. It's an optimization time. It saves time. This is really the worst optimization talk ever because it's not about improving your app. It's about cutting corners and saving time. So, you know, keeping it all together is pretty cute. Everything in the same place is good. Don't forget to optimize the environments. Yes, that is tuning your JVM and VMs. If you're running Docker, try running it on Alpine and stripping out everything you don't need. JVM, if you're running data science-based loads, you should really be tuning the actual memory usage in the JVM itself, rather than just relying on stock. Because stock is, in Java land, you know, that wonderful beast that's meant to be a Swiss Army knife that will do all of its workloads, but it just means it's really badly performant on web stuff and other things. So tune it, make it do what you want it to do. Next up, the top tier, Internet Explorer. So take everything closer to the user. It's pretty simple. If it's with the user, it's at the user's problem. It's on their browser, it's in their client, it does their things. Use CDNs being one of them. I can't find a GIF for CDNs, surprisingly. Oh, I thought I put the white logo in there. That's actually a thing called Cloudinary. They're a CDN company which does image manipulation and video stuff. So it dynamically generates all your CDN material and throws it at you for later, which is really useful. It's also free as well. I like free. Free is good. Yeah, so use CDNs. Use all these wonderful technologies that you don't have to own and somebody else can do the work on your behalf. Next up is progressive web apps. I know it's really a hype word, but I really love progressive web apps. I swear I should have been a front-end dev in another life, but databases. But PWAs aren't actually, it's not a technology or anything itself. Who here's heard of PWAs? Who here has written PWAs? Yes. It's actually just a broad collection of tools, roughly stated by Google, but it's actually completely open source contribution stuff. They're even discussing having a logo for it. Another browser-based logo. Right, so the technologies involved, service worker, wonderful thing. You can do background sync, periodic sync is on the way, push notifications. You can do all your data bits in the back of it. So you can have all this work be done on the browser, which means it's not being done on the database and not on the servers, and generally not killing your infrastructure. So having it on the client means it's the browser's problem. Admittedly, if you're setting fire to somebody's Chrome, you should probably stop. So next up, IndexedDB. Offline data sets are good. If you can put the data on their browser, it makes it quick for them to access. The joys of the modern specification means it's all segregated anyway. So it's sandbox. You don't have to worry about people looking at the information who don't belong to it. Because it's sandboxed to their browser, that tab specifically to them. Breathe. So you can actually throw the information in there and have it away from the servers. It's safe, relatively. Just, I'm covering my backside there. Allegedly, it's safe. Makes things a lot quicker. Next thing up, I know AppCache. AppCache is a douchebag by Jake Archibald, but it still works in Safari because Safari is old and broken, and you can still store things offline even though you can't use Service Worker. Then there's all the usual JS, CSS nonsense, minify it and throw it places, make it do its thing. I'm not going to tell you about that because the internet tells you everything about that. And I forgot. Don't forget about caching. There's this wonderful thing. There's like 18 different major cache technologies from Redis, Memcache, Varnish. You can throw them at different points. You can put them on an API. I see the time. You've got this wonderful thing. It's doing. You can throw at these APIs. So if you have a noun-based resource API, a knowledge API, you can throw just pre-caching all the information, have it really, really close to the end user in a data system directly behind the layer. 2 steps, and it's with the user. And you can do this at any point. You can partial cache HTML, you can partial cache data sets, you can partial cache code. Yes, I've seen this done. Mainly in CouchDB. So, takeaways. Oops, I broke that slide. Big takeaway. Take everything to the user. Optimization isn't necessarily improving the code. It is primarily just making things run quicker. And I forgot to put a slide in about this, but I've just realized it's important. Don't optimize early because you will never find the fire if you're trying to cover your backside early. Wait for things to start burning. Yes, I know that's bad, but run profilers. Find out where your application's actually hurting. Is it in the framework? Is it in the data layer? Is it something in the pipeline that's causing a giant pain? But profile and find it out afterwards. So that's who I am. Any questions? Really? Oh, we have one question. No questions? Seriously, I like being... Oh, God, the troll.
Can you tell me which NoSQL database you prefer?
Oh, God.
It's an open question.
I'm going to go with the fact that I'm going to get trolled about this in a moment, so Redis.
But why?
Because it's fast and it's quick and it does queues and it does pub/sub and does blah-de-blah-de-blah-de-blah-de-blah-de things, spec sheet stuff.
Correct. Okay, so you suggested a whole bunch of different things. How do I know where to start? What would your approach be to actually kind of take an approach to this?
The whole thing about this was you're trying to save time, not make things improve, because bad code is still code that works. So in my humble opinion, you should wait till things are on fire and profile. And when you profile, you should then optimize the bit that hurts.
Okay, so you're saying at least have some measurements in place to measure where the potential fires are going to arise.
Yeah, so monitoring, logging, checking, which I should really have included. But yes, pre-optimization is actually a curse because you end up with people sinking hours and hours and hours into research on stuff that inevitably never becomes a problem because the user doesn't use it. How many people have written features which never get used and they put so many hours in it they've felt heavily disappointed that they were so smart and clever and optimized and they're never used? Wait till it burns and fix it later. I like fire. Are we good? Sweet, we're one talk away from beer.